मैं आपको होस्ट है ना मैं आपको होस्ट है ना बना रहा
हम्म।
हूँ। ओके, होस्ट हो आप, ठीक है, और लाइव हो।
ओके। सो हेलो एवरीवन। आज वेलकम टू न्यू सेशन। आज नया सेशन में हम शुरुआत करते हैं। तो आज हम एक एआई बेस्ड सिस्टम बनाएंगे जिसमें कि हमारे हाथ को ट्रैक कर सके रियल टाइम। और हम रियल टाइम में हम उस हाथ को ट्रैकिंग को हम बाद में कैसे सर्वो मोटर को कंट्रोल करने में यूज कर सकते हैं, या फिर रोबोट आर्म बना सकते हैं जिससे कि हम अपने हाथ के ट्रैकिंग से ही कंट्रोल कर सके सर्वो मोटर को। तो इसमें हम सेंसर का यूज नहीं करेंगे। आमतौर पे लोग सेंसर यूज करते हैं, बट वो हमारा बहुत सारा वायर्स हो जाता है। इसमें हम सिंपल एआई इमेज प्रोसेसिंग का यूज करेंगे जिसमें कि रियल टाइम में हमारा हाथ को ट्रैक होगा और वो फिर उसको सर्वो मोटर में ट्रांसलेट करेगा। ओके। जैसे कि इस प्रकार का आप रोबोट आर्म देख सकते हो। रोबोट आर्म, इस प्रकार का ये जो रोबोट आर्म होता है, इस प्रकार का रोबोट आर्म को आप अपने हाथ से कैसे ट्रैक करके कंट्रोल कर सकते हो। तो यहाँ पर मैंने एक बेसिक सा ये रख रखा है यहाँ पे, जिसमें कि हमने इंडस बोर्ड पॉइंट को यहाँ पे कनेक्ट कर रखा है। इसके ये
अश्विनी,
हेलो।
अश्विनी, सेकंड कैमरा इज नॉट वर्किंग।
ओके ओके ओके, लेट मी शेयर द सेकंड कैमरा। Can you make me the host? Yeah, okay, okay. I am okay. So now you can see the second screen. This screen is visible. Okay. So now here what I have set up is the simple two-axis gimbal, like what you see in this kind of robot arm. Okay, with the servo motor, and I have connected this servo motor with the Indus board coin to the pins number 18. Okay, so currently I am using only one servo, as you can see here. As you can see here, and this is the Indus port coin I have connected with the FPC. So this can be controlled using my robot. This whole things can be controlled. This robot arm can be controlled using my hand movement, this hand movement. So I can move this hand and I can control it. So how we can do it? Okay. So today we are going to make such a robot that can track my hand in the real time and can able to move this servo motor arm. So let me show you a little bit of demo. So here is one of the code that my code is running. So now whenever I move my hand, it can track the hand in real time, and then it can translate that hand into the movement of servo. So you can see here, it is tracking the hand in the real time without any lag. See, it's tracking in the real time. See, so it's tracking my hand in the real time, and this hand is then can be translated into the servo movement. Okay. So for that, I can connect this to this one. Okay, to my board, and then it can track and move my servo motor. You can see here in this window. You can see the hand tracking can translate into the this motor movement. Okay. Okay, so this video can the video that you are seeing here, the video that you are seeing here, it can track the movement in the real time without any lags. So how you can make such things that can track the hand in the real time? It can track even my both hand, and I can translate this hand tracking to the servo movement here in the uh, here on my desk. Okay, so we are going to use the same thing. Okay, so how we can do? Earlier we use most of the system use the IMU sensor to track the hand movement, but that needs to be wire go from the hand to the MCU or some kind of wireless streaming. You need to stream the BL data of that IMU to the device to control it. But here we can do it wirelessly without that. Okay. So so how you can make it? So we will use the MediaPipe AI model to track it. Okay. So whenever I connect it, as you can see here, my servo is connected. My servo is connected. So whenever I connect it, okay. Whenever I connect it, so this is the thing. So here the power is little bit loose. This power line is little bit loose. So that okay, but it's okay. now when I plug it and when I connect there, you can see this servo motor will move. Okay, this servo motor will move. So I'm connecting it. Now it is on. Hope the power is going there. Power is going there. Hope. Yeah, power is here. And now when I connect here, this thing. Okay, this thing, this servo will move as per my hand tracking. Okay, some connection is loose here. Okay, so let me upload the code here in the, let me disconnect it and let me upload the code for the servo movement. So for that, first we need to make the servo movement code. So this is the servo movement code here we are using. Okay. So here we are using the ESP32 for the servo movement. Okay, the servo we are connecting here. Okay, the servo motor we are connecting here. Let me show you the second screen. Yeah. Now second is the servo motor that we have connected here. So for this movement, we need to make the Arduino code here and this program the this board to make this board move. So here what I am using here, this code is tracking my head and translating that hand movement into the XY coordinates. Okay, and that XY coordinate need to be transferred using the serial port. Okay. So for that, I need to create a code that this board takes the serial input in the real time. Okay, takes the serial input in the real time. This board takes the serial input in the real time using my PC. Okay, using my laptop, you can see this is connected to my laptop here on the USB. You can see in the camera here. See, it is connected. Okay, so this whole thing is connected. Okay, now I can either use the multiple of axes like X, Y, Z, and for different axes I can use the different pins. So currently I'm using only one axis, the X axis, like I can move the hand like this to control the servo motor, so that this axis can be translated into the coordinates to control the servo motor. So for that you can, I am using the pin number 18. So any pin on the board, if you are using ESP32 or if you are using the Arduino, then you have to check the which pin is this whole thing can work on the different over the USB, ESP32, this Indus board coin, or even in the Arduino, but you need to change the code according to their pins. Okay, so you have to check which pins are the PWM for the Arduino, like pin number 9, 12, and 8, 9, 12 or something are the PWMs enabled. Okay, for ESP32 also check the what are the pin numbers. So here I am using the Indus board coin. So benefit of the Indus board coin is that the Indus board coin has already inbuilt pin, already many, what's it, yes, this Indus board coin has already all the GPIOs, that 30 plus GPIO, all these 30 plus GPIO that you see in the Indus board coin. So all these pins that you see in the Indus board coin are capable of PWM signal. So I can connect to any of these pins. Okay. So here I am using the FPC board in my setup. So this FPC board first pin is pin number 18. So I am using the pin number 18. So if you want to add one more servo here in the code, okay, so you can simply copy this and add my servo pin 2. Okay, and define the other pins like 12, 13, 18, 19, or 11, whatever are the pins I can, and then I will start my servo. Okay, So if I am using the another servo, so I also need to define the another servo here. For suppose that I am using the servo 2, so my servo 2. Okay. If I am adding the more servo to the other pin, so my servo 3, my servo 4, you can name anything that for the servo. Okay. So this is the will be the name of the servo motor that you connected. Okay. And then we will use servo dot attach to the servo pin, which pin you have attached the servo. Okay. So my servo, here I am using the my servo. This first servo is connected to the pin number 18, so servo pin. Okay. So if I want to attach one more servo motor, so I can simply use my servo 2 dot ATTAC attach, and whatever the pin, the servo pin 2 or 11, I can simply write it here 11 like this, or simple write it like this. Okay. And hit enter. Okay. So you can make it like that. Okay. So after that, this thing you need to set up, and then you will have to start the serial port, and it will check the incoming strings, incoming data from the serial in the real time. So if it sees the if it sees the degree, the angles that it will translated from the this video, that video that we are running here, this video that you are running here. Okay. So this video will generate the XYZ coordinate, and this XYZ coordinates of my hand tracked hand is then transferred using the serial in the string format, and then it will trim the both values, X value and Y values, and then move the servo angle to the that angle. Okay. So when I upload this code, it start taking the serial inputs from the PC, from the USB. Okay. So currently it is taking the serial input. Okay. Now for the MediaPipe thing. So for the MediaPipe here, I am using the Web API. You can also use the Python. Okay. So there is another code for the Python here. You can see when I run it, it can also track. Now I'm running the Python model, Python AI model. So after a few seconds, the window will appear. It is loading the MediaPipe thing. After a few seconds, the video will be available. One second. Let me run this model again. So there are both models. The Python model where you can also create the code in Python and take the serial input from the Python, or you can use the Web API like this one. This is the Web API thing. Okay, so this Web API will track the hand, and this whole thing run on the web, the HTML code. Okay, so both options are available for you. Okay, so see the new video has appeared. You can see this is the new video of this camera, the second camera. Okay, so I can move this camera. Let me move this camera. So you can see the second camera now. Now it can track my hand. This is a Python code. See, it's tracking my hand. It can even tracking my second hand. See, in the real time, and very fast. It's very fast. It's very fast in the real time. It's tracking my hand. And this hand, then tracked hand, can be translated into the XYZ coordinate and transfer it using the USB and convert that XYZ into the movement of this second. So this camera got disconnected. Okay, this camera got disconnected, the servo one. Okay. So that can track in the real time. So let me explain the Python one code first. Okay, then we will go for the Web API thing. Okay, then we will go for the Web API. Okay, so here in the Python code, I am using this code. So you can see it's tracking my hand. Okay. So here in this Python code, I am using the OpenCV to for capturing the video. So this thing is for just for capturing the video to start this camera camera that I am using here to start this camera, and then capturing the frames of from the camera. So it is not processing the whole video; it is processing frame by frame. So currently this whole system is able to process the at 60 fps. Okay. So it's very fast. It's not missing any single frame. You can see here in the video. Okay. So it is using the OpenCV2 to capture the video and then transfer it into the frame and then process that frame. So you need to install the CV2 for video processing and basic processing. And then we are using the MediaPipe for this. So this hand tracking we are seeing right now here is done by the MediaPipe. Okay. See, this hand tracking that is happening here is done by the MediaPipe in the real time. Okay. So you can download the MediaPipe model from here. You can download the MediaPipe hand tracking model. Here you can see this hand line one detection. So you can click there and then download this model. Okay, and then you need to also install this model. So both things, MediaPipe and CV2, you need to install. So to install these both things, here what you need to go. If you are using the Raspberry Pi, then you can open the terminal. I am opening the new window in the terminal. If you are using the Raspberry Pi, or if you are using the Linux, you want to anything, or if the Mac OS. So what you need to do, you need to for installing the OpenCV2, you can type sudo. If you are using the Ubuntu, then you need to use the sudo. If you are not using the Ubuntu or any Linux, then like Mac OS, so you can directly type PIP3. If you are using the Ubuntu sudo, or if you are using Raspberry Pi or NVIDIA Jetson, it can work in all those environments. NVIDIA Jetson, Raspberry Pi, Mac OS, or any kind of PC. You just need the Python and the MediaPipe library. Okay. You just need these two things. Okay. Raspberry Pi, Python, and the MediaPipe library. Okay. So only you need only these two things. Okay. Uh, and for the servo motor control, you can use any the Arduino, the ESP32, or Raspberry Pi. But you can directly control from Raspberry Pi as well. You can use the Indus board coin. So I am using the Indus board coin because it has large number of GPIOs, so I can control n number of degree of freedom like X, Y, Z, and right turn, left turn. I can control many servo motor using this. Okay. Using the Indus board coin. Okay, that's why I'm using the Indus board coin. It's very small, so I can even make it the wireless, so it can make the web sockets and it can wirelessly control the servo motor. Okay, using my hand tracking, this hand tracking. Okay. So whatever the platform for the servo motor control, you can use. You are free from Indus board coin to ESP32, the Arduino you can use. And whatever the platform for this AI processing, this MediaPipe AI processing, you can use. Like for the Raspberry Pi, you can use. You can NVIDIA Jetson, you can use. You can NVIDIA Orion, you can use. You can use the SS Tinker board. You can use the Mac OS, this laptop as well. You can use the what's the you can use the Ubuntu laptop, anything you can use. I am using here a laptop. So for all them, the command goes the same. How to install this, the MediaPipe and OpenCV. So you can simply type open the terminal. If you are using the Raspberry Pi or Ubuntu laptop, so you open the terminal and type sudo pip3 install open cv. Okay, or you can also type OpenCV Python. Okay, if you are then you need to install the MediaPipe. So for installing the MediaPipe, you need to do same MediaPipe sudo pip3 install MediaPipe. Okay, so when I enter, I have already installed, so I am going to cancel it after entering it. So when I enter, it will take it will ask me the password, and when I enter the password, it will start installing that. Okay. Okay, I start installing the MediaPipe. So after installation and after installing the OpenCV and MediaPipe, your environment is Python environment is ready to track this hand. Okay, but you need to make the code and you need to download the ML model for that. So this hand tracking needs the ML model. So I have already told you need to download this hand landmark detection ML model, and then you need to keep this in the same folder. Like here, you need to keep this ML model in the same folder. This, see, landmark, this file. Okay, so you have to keep where you kept the code. If you are keeping this file in elsewhere, not in the same folder where you are keeping the code, then you need to set the path here in the code. Here is the path configuration, model path. Okay, see, hand landmark detection dot task. So my code, see my code, this hand landmark dot py code and the model ML model is in the same folder. So I can simply name it directly like this. That's why I ask you to skip the model and the code in the same folder. Okay. Once you have done that, okay, if you are keeping it in somewhere else, like in the download folder, so then you can set the path downloads and the name of the model. So you need to configure the path of the model and model name to run the model. Okay. Okay. Then after that, here what I am going to do, you can see in the while condition, I will use the OpenCV, this OpenCV to start the camera stream. Okay, this camera stream start and then take the frames. So it will stream the video in the real time and then convert that whole streamed video into the multiple frame and continuously process this video and convert this into the this RGB to BRGB, blue, green, red. Okay, this format, and then again it's resize the image to process it much faster. Okay. Okay, after that, okay, it will call this model, this ML model, and try to detect the hands. Okay, like my face, it is not detecting it, it's not tracking my face. Okay, it try to first detect the hand. After detecting the hand, it will try to track the different landmarks on the hand. Okay, landmarks on the hand. Okay, in the real time. See. So it is detecting the landmarks. Okay, so it use the model and try to detect the hand, and then it will detect the landmark, and then it will give you the output video like this. Okay, of different landmark. Now in the landmark, if you want to get the coordinates of any particular points, okay, like here. Let me close it. Like here, coordinates. Okay, so for coordinates, you can modify the codes and get the coordinates from here. What are the coordinates of the detected hand? Okay, if it is not detecting any hand, it will simply show that no hand detected. Or if it is detecting hand, then it will give you the result, okay, of landmarks. So you can get the hand X, Y, Z are different landmarks coordinates using this result on hand landmarks. And then later you can use the Py serial. This is another library for Python. I'm telling it for the Python. Py serial. This Py serial library. This helps you connecting the. This is not the original Py serial. Let me show. Let's see. Yeah, this is the original Py serial. Okay, so you need to install this Py serial. This library help you to connect your laptop, this laptop, my laptop, with the what's it? Oh God, with the Indus board or any kind of other board to bridge over the USB serial to give the coordinate data and then transfer that into the movement of this servo motor. Okay, into the movement of the servo motor, into the movement of the servo motor. Okay. So for that, you need to install the Py serial. So you need to open the terminal again in the laptop, Ubuntu laptop, macOS laptop, or Raspberry Pi and NVIDIA Jetson. What the command will be the same to the all over the platform, and it can be done on any kind of platform. So there is no restriction with the platform. You can use the laptop, you can use the macOS, you can use the Ubuntu, you can use the Linux, you can use the Raspbian, you can use the Raspberry Pi, you can use the NVIDIA Jetson, any platform is not restricted for my technology, for the design what I make. Okay. And same for this servo motor controller using the serial bridge. So you can use the Arduino, you can use the Raspberry Pi, you can use the ESP32 board, you can use the particle photons, you can use the Adafruit board, you can use the Indus board coin. No restrictions with the platforms and the technology. Okay, so I am using the Indus board coin right now because it's very small and it helps you with the lots of GPIO already inbuilt, so that you can connect many servo motor at the time if you want to expand this for the main all these kind of track point, all these different track point, as you can see here, all these different track point like 1 point, 2 point, 3 point, all these point 1 2 3 4 5 6, all these track point you can control individual servo. So like 30 40 50 tracking point, you can control all the servo motor of different servo for each tracking points. Okay, so more higher level. So that's why I'm using the Indus board coin here. Okay, yeah, so for that you need to install this pi serial library. Okay, so here let me go hide it somewhere. Yeah, here hide it. Okay, pi serial library. So you need to open this the terminal and simply type sudo pip3 and then paste pip3 install pi serial. So if you're using Python 2, you can use the sudo pip install pi serial. If you're using Python 3, I'm using the Python 3 and pip version 3. So I'm using the sudo pip3 install pi serial. Here for the installation command, you will see pip install pi serial. So this is for the Python 2. Okay, if you are using the latest version of Python pip3, then you have to write sudo pip3 install pi serial. After this, it will install the pi serial library. Okay, see. So it's already installed. So it will show me the requirement already satisfied. Okay. So after that, once you install the pi serial, you can then modify the code. Here you need to import the pi serial. Here in the code, you need to import the pi serial. Then you need to define the port number, and then you can translate that. You can send this hand landmarks to the over the USB to the device that we have made, and then it will take the data from the USB and it will control the that servo motor in the real time by tracking the hand like this. Okay, like see, it's tracking my hand in the real time. Okay, so that's all for this. So this is a babe version. This is another babe version. So for the babe version and controlling this servo motor in the real time with the real time demo, I will take one more session, maybe next month. Okay, then I will give you the whole demo of this thing, how to controlling the servo, and I will give you the more depth on connection of the servo, the power supply of the servo, power management of the servo, and whole controlling thing of the servo using the tracking hand. And for the each tracking hand, I will use the different servo motor. Okay, so I will control 10 to 5 servo motor in the next sensor using my track, all this track one. So we will take one more session on this. Okay, to give you the more depth of the many tracking points, and on the babe version, this babe version. So this babe version I will take one more, and for the servo many servo control. Okay, in next month. Okay, for now we are using the Python version. Okay, this is a Python version. I have told you what to do, how you can design using the Python. So if you are using, if the Python programming installation seems very complicated to you, then you can use this kind of babe version for the tracking. So this is the babe version of the same code. So I will tell you how you can make the babe version as well. So in babe version, you don't need any kind of installation. You can just keep this file, this HTML file, to anywhere in the phone, in the laptop, anywhere. Okay, even in the TV it can run. Okay, yeah, it can run in the TV as well. Okay, and you can simply start, and it can start tracking the hand in the real time without any kind of installation, and it can connect to the Indus board, and it can control you can control the servo motor in the real time. See, it's very fast. See, it's not missing any single frame. It's very fast. See, it's very fast. It's all controlling the real time. See. See, it can even track my second hand. I can even make the keyboard. Okay. Okay, thank you everyone. If you have any kind of doubt, then you can ask me. Okay. So if you have any doubt, you can ask me in the comment. Okay. And then I will answer you in the next session. Okay. Thank you everyone.
अश्विनी होस्ट एक बार बनाना, यूट्यूब का बंद करना
मैं इधर से बंद कर दूं सर, यहाँ से हो जाएगा।
ऊपर से यूट्यूब।
हाँ, स्टॉप स्टॉप